Welcome all of you. So in this video we will talk about how this electrical energy now it's crazy, man. Electrical energies can be generated by your sweats, and this is a new thing. Like there are few discoveries, few inventions already there which can utilize the sweat to convert into electrical energy. But those sweatenings, it require intense activity. Like it's not a minimal sweatenings can convert into the electric energy. There's a huge amount of sweatening you need, and for that you need to generate lots of electricity. So that is a one terminology. Whenever the investment we talk about is called the return on investment. On the same time, here people are taking about the return on energies. Like for generating the some kind of small energy, if you need to do some intense activity to generate a sweat, and then some small fraction of energy is generated, so it is not effective way. So before these inventions, the kind of conversion happening is less than 1%, okay, in form of return on energy. But now what's happening, these invention where they have utilized these carbon nanotubes and some kind of hydrogel, specific hydrogels. If you need detail on that, just DM me, we will talk about on this. So the combination of that, they're able to produce energies up to 300 millijoule of energy while you are sleeping. And the sleeping time, like about 10 hours of sleeping, like without any activity, without anything, you are just sleeping. So, and during that sleep, whatever the sweat is generated by your fingertips, so those sweat is get converted to the electric energy. And how much is 300 millijoule? These are not a concrete, these are the rough estimations, and like they have designed it, but it's not possible that each and every person, if going for a sleep for the 10 hours, they able to produce such kind of energy. It's not, yeah, but this is in general what they have observed. So what is the best part of that? Like in throughout the day, you able to generate about 1000 millijoule of energy. Even if it is not a summer day, like if doing some simple activity like physical, like typing or some the normal hand-on experience, like hand-on activities and all other things, able to generate about 1000 millijoule of energy. Like this is a rough estimation which is made by me myself by understanding this research. So I think this about 300 millijoule to 1000 millijoule of energy is sufficient to run any small kind of sensors or some sensor devices, something. But again, in some of the video, well, I talk about like how much energy, because which kind of sensor you want to sense, like which kind of physical activity you want to sense, or which kind of application, like sensors application you want to employ, because each and every kind of sensors having the different needs of energy. So definitely it is a cost effective way, because you are doing nothing, you are doing your normal activity, but still you are getting some good amount of energy on this. So it is definitely useful. But while we're talking about any kind of sensors which able to detect something, then it is a very caution, like which kind of sensor they can utilize such kind of energy for a whole day. So that is one of the questions. So and definitely is the first step, so people need to optimize it, and we can do that. And apart from this, what is the best part? They design such kind of hydrogel having this carbon nanotubes. They couple with some piezoelectric effects and piezoelectric system, because piezoelectric also, like it able to generate energy from your mechanical movement, or mechanical energies can convert to the electrical energies. And what they have seen in their device, these conversion is about 0.5 millijoule one movement. So and the sweatening, they're giving the 300 millijoule. So that is very commendable. But apart from that, like if you want to understand like how these things, because in sweat there are so many molecules, so many biomolecules are secreting out, but in the sweat is major component is lactate, and for this conversion also they need the lactate. So in their hydrogel, why they use the hydrogel? Because the hydrogel can absorb that sweat, and that hydrogel is embedded with some kind of bioenzymes, and once this lactate get absorbed in the hydrogel, the lactate and bioenzyme, there is an electron transition happening. Once is active in cathode, another is active in anode. So when the electron is moving from cathode to anode, these things are happening, this circuit is get completed, and the energy we can generate it. But so this is one thing, but the question is that once like this is kind of electrochemical cells, is a miniature form of electrochemical cells, if I can say. It is a biomechanical cell. So if it is a biomechanical cell, so this conversion, how long it's going to convert, because we see any kind of chemical cells or such kind of where this electrode and this kind of in a bigger form, bulkier form, wherever these things are available. So there is a fixed number of conversion can happen, like how long this conversion can happen, like after getting electron transfer, it has to again revive it. Those, especially the bioenzyme lactate, you will always get a new form, like not new form, like new amount of lactate you will always get by the sweatenings. But so the source is unlimited in the case of the lactate. But in the bioenzyme, whatever we have embedded in the hydrogel, so once it get activated, then again it need to be deactivated, like again it need to be in a another form. So this conversion is can be the issues, like how long it will show this kind of biomechanical cell behavior, like how long it can goes up, because each and every, for example, lithium polymer, we can charge it, and then again this electrical cell, like this battery, can again discharge it, and then again we charge it. So charging and discharging cycle has some limited period of time, like, and after so many, then there is a decrease in the charge, this charging and discharging thing. So that thing they have not mentioned, like how long it can be done even at their smaller scale. So that is one of the questions. And and apart from the design they say the very simple design, people know, but it is very very odd to wrap up anything on your fingertip, even if those are very tiny or thinner. For example, they are claiming that this is carbon nanotube, and they utilize, so this very thin is not noticeable and all, but still I don't know, it feel very odd to cap it over these fingertips. So on a design part, they need to develop, like how we can how they can harness this energy in different forms, or in which way, like they need to develop something. So they are saying that they can develop some kind of gloves and all. So yeah, so that could be another thing. But maybe for some people it is a matter of the choice, but the people who actually, especially the diabetes people, who have to take the insulin by time, and that insulin device they attach on their body, and they having generally like some external source of energy, like in a form of battery or anything. And apart from that, there is some piezoelectric system is already there, so by body movement that cells become charged, and then it able to deliver those insulin. So again, the efficiency are very less on those diabetic devices. So if we able to generate such kind of innovative technique, what the people have invented it, if we able to optimize it, and if we able to put in a such kind of diabetic devices, then definitely the compactness of those insulin delivery devices become much more. And because sometimes some people want to use this insulin cartridge with that particular 23 degree centigrade temperature they want to maintain, because the insulin, once the temperature increases, there is deterioration in their capacity. And I also try to make such kind of insulin delivery devices, but I'm not get success on this. So, and I also have the same thought, like can we give such kind of surrounding temperature, but for that we need a more energy, and then there is no more compactness in the insulin delivery devices. So if we able to generate such a efficient way of this energy harvesting, then definitely if we making the combination of the piezoelectric and making the combination of the sweatening thing, then we not only able to make a compactness, but also a very efficient, energy efficient device also. So yeah, so it is having the good future for this kind of things, these devices. And apart from some of the pacemakers, people also can utilize it. So that is a question, like how much energy we can generate, can be more increased. And another things they are claiming, like by sleeping you able to generate 300 millijoule of energy, but by just pitching your fingertip in a single time, those device can able to generate 30 millijoule of energy. Still those are much more higher than the mechanical energy they have generated in their device, which is about 0.5 millijoule of energy. By mechanical energy conversion to electrical energy, they are able to generate only 0.5 millijoule, but here the single pitch able to generate 30 millijoule of energy. So definitely this is a very huge result, very good result, and very promising research work. So let's hope for the more innovations in this, and for more design development and all. So that's it all about. And if you need a further discussion on that, further explanation on this, just DM me. So we will meet another video with some another topic. Till then, bye, take care.